Okay, so we are on page 206 and we're looking at bearings. So there's two ways to work through bearings. So the first one is always going to be relative to north. And not confusing at all. Now we're going in clockwise direction as opposed to our angles in standard position, who started on positive X and went counterclockwise. So here we're starting at north and we're going clockwise 125 degrees. Okay, so if you take a look, and right here, bearings north in a clockwise direction. So here, if somebody asked you to go on a bearing of 60 degrees, you're standing here at the origin, you're looking north, and you turn clockwise 60 degrees, and that is going to be your bearing of 60 degrees. If I want 240 degrees from north, going clockwise, 180, and then another additional 60 degrees. Okay, and so bearings, really important if you are a pilot, if you are driving a boat, if you're outdoors and you're using a compass, and you want to go through bearings in that way. I know those of you who were in OE last year would have learned about bearings in this way. Diving, part of diving, if you do your advanced certification, there's a navigation component to it as well, where they go through diving. Yep, scuba diving, exactly. Okay, so let's take a look at how we can do this. So looking at class example number 2 on page 207. So we've got a liner leaving port P, and it sails 15 kilometers on a course of 37 degrees to a position Q. Okay, so our liner's at point P. If it sails 15 kilometers to Q, we know that this is 15 kilometers. The tricky part is this. Some people go, oh, 37 degrees. That would be incorrect because it must be relative to north. Okay, so what I strongly suggest that you guys do, for all of these questions is draw in north. In some cases, it will also help to draw in south. In some cases, it may be helpful to draw in east and west as well. And it now changes course to 270 degrees. So from Q, okay, what do we know? Here's north again. So you can see this whole thing would be 270. I don't need to draw that in. What's probably important is that that is going to be 90 degrees, right? Again, might be helpful for us to draw in south as well. Okay. And then we are looking at, sorry, I forgot. It's sailing 12 kilometers to R. So this is our 12 kilometers. And we need to know if we are now at R, on what bearing must we go to get back to port? So this is north again. Okay, so the bearing that we are looking for is from the north down to P. So we know that this is going to for sure be more than 90 degrees, right? So let's take a look at this. Then what can we find? Reminders, okay? And you're going to want to write this a little bit smaller. But a couple of reminders for angle relationships. So first one is if you might have a letter F. So basically, a lot of these angle relationships come up if you have parallel lines. So on an F, we have the two parallel lines and a line that touches both of those lines, and that is called a transversal. These two angles here are equal. Okay, so if we have our parallel lines, the transversal that intersects those two lines, the angles created, it makes sense that they will be equal. If I take part of the F, and we'll call it a U, again, parallel lines, transversal along the bottom there. These two angles, obviously not equal. One is obtuse, one is acute in this case. They have a sum of 180 degrees. They are corresponding angles and supplementary. Okay. The next letter, and this is the one that's going to come up a lot with bearings, look for the letter N or the letter Z. The letter N, when we have our parallel lines, the transversal, those two angles created are equal. So angles are fun. Just put it up there. Okay, and the last letter is kind of what we had mentioned already. Anytime you have an X, opposite, so intersecting ones, opposite angles are again equal. So when I go back to my diagram, look at that 37 degrees. Where can you get another 37 degrees? Sorry. How did we jump? There we go. Okay, so if I know that this is 37 degrees, because we have here this letter N or letter Z, backward Z, so we can see that those are equal. Okay, then how can I find angle RQP? How do I know what this angle is? Don't need to. Okay, so now that I know those angles, where else could I find now any of the other ones? It doesn't matter. It does not matter which way you find the 53 degrees, whether you use the N and get that other 37, whether you draw the letter, you draw and make that right triangle to make it 90, 37, and 53. Either works. Okay. Which angle are you going to find next? What do you think? Because we've got length P. Okay, so we know that we have P is right here, is 12 kilometers. We have length R is 15 kilometers, and we now have angle Q is 53 degrees. Then we can find length Q, because we need to know the distance that the boat must sail to return from R to P. So let's start there. So Q squared equals P squared plus R squared minus 2PR cosine of Q. Substitute everything in. So 12.3 is Q, good. Kilometers. Okay. So now that we have the three lengths, can I find angle QRP? How do I find this angle theta right here. You can do it in a few ways. How do you find angle QRP? Show? So I would totally do sine law. Yep. Okay. If you have the option, grade 11s, of doing sine law versus cosine law, so first off, take a step back. What would you rather? You're always going to rather using given values instead of found or rounded values. Second thing to consider, think about which formula has less moving parts, which is simpler. Sine law, so much simpler than cosine law. So if you have the option, I would always do sine law. Okay, one, not only will you get something more accurate than using cosine law, but you would also lessen the chance of making mistakes. Okay, so we've got sine r then over r is equal to sine q over q. So fill everything. Once we have the ratio, we know that sine ratio is positive. It could be quadrant 1 or 2, right? So then angle R is going to be the inverse. So I know that this could be quadrants 1 or quadrant 2. Okay, so what is my angle R? 77 degrees. Why can't it be 103 degrees? It just doesn't work because look at the angle in the triangle. It's an acute angle. It's not going to work. Okay, so we know right off the bat that quadrant 2 isn't applicable in this particular case. So angle R is 77 degrees, which means what bearing are we going on? No, because it's relative to north. So it would be 90 plus 77, so 167 then. Okay, so the bearing is going to be, whoops, with an N in there, 90 degrees plus the 77 degrees is 167 degrees. So that is from north down. So to answer the question, complete the sketch, calculate the distance and course. So it's going to be 12.3 kilometers on a bearing of 167 degrees. There is an alternative way of describing direction. So bearings, I think most people use relative to north. That's kind of the standard. The other way to do it is always going to be relative to north or south. So basically, we could have a bearing of 125 degrees. So there's 125 degrees right here. That's the bearing. However, it could also be that it is 55 degrees east of south, meaning start with south and go 55 degrees towards east. So that is 55 degrees east of south. Okay, so start with south and then we're going this way 55 degrees. So it's not always going to be clockwise. It's not always going to be counterclockwise. It's basically saying, are we closer to north? In which case we're going 20 degrees west of north. Or are we closer to south? And then we're going 60 degrees west of south. Are we closer to north? Going 60 degrees east of north. Okay, so it is important that you remember, never eat soggy waffles. Class example number 4. A ship observes a lighthouse in a direction that is 50 degrees west of north. So we've got our ship. So I'm going to just call it B for boat because I don't want ship S to get confused for south. Okay, so the lighthouse is, let's take a look. So here's north. So 50 degrees west, that is going towards the left. So this way, 50 degrees, right? So we're seeing a lighthouse up here. Lighthouse. And this is my 50 degrees. This is north. Okay, so a ship or boat observes a lighthouse in a direction of 50 degrees, that is west of north, but it's going to actually sail 36 kilometers in a direction that is 35 degrees west of south. Okay, well, here's south, and we're going 35 degrees west of south. And how far do we sail? Is we're going to sail far enough that the lighthouse ends up being 15 degrees east of north. So this is 35 degrees. Okay. And how do I know that essentially I'm sailing and I need to kind of come past the lighthouse? Is because the lighthouse is going to be, we're going to keep sailing until the lighthouse is 15 degrees east of north. Does that make sense? Okay, other than this line is poorly drawn. So let's try using my ruler. It's going to get better. There we go. Maybe I'll fix this one too. Okay, so we know that the lighthouse, this little sliver is 15 degrees. And what else can we add to our diagram? Oh, the boat had sailed 36 kilometers. Okay, so have we covered everything? Does our sketch demonstrate everything in the description? I think so. Okay. Calculate the distance the ship is from the lighthouse when the second observation is made. So that's going to be this distance right here. Okay. So what can you tell me? We know that's 95 because this whole thing is going to be 180 degrees. So 180 minus 50 and minus 35 gives us the 95. What else can you look for? Can you see a letter Z somewhere? That might be helpful. Yep, Rohan? Yes, it is indeed 20 degrees. Okay, and you knew that because? It's 35 minus 15. Yeah, so because right here, there's that letter Z right here, a backwards N, right? So we have 35 degrees, but part of it is made up with 15 degrees, and therefore the rest of it is 20. Do you guys see that? Okay, now that we know that, I think we're almost there. What else do we need? What else is going to be helpful? Yeah, angle L, which is 75 degrees. So we know this is 75 degrees because angles in a triangle add up to 180. So if it's confusing having all of these little pieces there, sometimes drawing the triangle separately is helpful. So I've got this as 95 degrees. I have this as 20 degrees. This is 75 degrees. This is 36 kilometers. and this is my D. So when we look at this, what can we use to solve for our missing length D? Sine law. Do we have an opposite pair? Yep, we do, the 75 degrees and the 36 kilometers. So you can then set up sine law. It is absolutely 65. Thank you. Hey, no, that's not, oh my gosh.
It's not wrong though.
65, I like that's better. Sorry, thank you. Thank you. Okay. Okay, there we have it then. Okay, 40 kilometers. Then, okay. And that is that. So 2 different ways of working through bearings. My biggest suggestion would be to draw in north and south. Sometimes east, west might be helpful, especially when you're trying to find those letter N's, especially letter N or letter Z, to find those equal angles. Okay.